Hello everybody, welcome to my channel. So in this channel I show my DIY projects, and this is the 3D printer that I have converted already to pick and place machine. And to set this machine up, it's a tedious job. I got quite some requests to show how to set up the machine from scratch. So in this video, I'm going to show you step by step how to set up the newly built pick and place machine, and then make it start the first job for you. If you are interested in building your own pick and place machine, you can go to my website xpdiy.io. In here you can find the models to download. There are free models, there are also extended model, and you can also do the subscription here for €30 per year that you can download all the digital designs. In case you have any ideas or thoughts, you can leave a message here. And you can also subscribe to my YouTube channel, then you can get the latest updates. Okay, so now let's get started. So as you can see here, this is an OpenPNP empty instance. Usually when you don't have anything set up, you just open the OpenPNP, you will see this screen. To set it up, OpenPMP comes with a very handy issue solution. It's like a wizard, so you can actually use this one to set up your pick and place machine. So at first, there are type of heads. So for us, it's a standalone nozzles. You can also set to different type of other nozzles. So basically, you can click on OK, and here you will actually remind you there are some other stuff, or maybe something you need to be aware of. So in here I just use yes, and then here it's proceed to connect, so it's basically okay. Then basically we set up the first step, which is to select what kind of nozzle head it is. So now come to the second step, which is the connect. So basically we have, in this case, we have a top camera, we have a bottom camera, so we can actually connect the camera, that it actually sets the camera not to the simulated one but the real one. And then this driver we can also then place with the G-code driver, and then we can actually do the issue and solution. Then actually it will ask you to choose the communication ports. That's also straightforward. You just go to here, driver, and then you can go here. And for me, I know that the driver here is used serials, and then the port is USB 2. Actually, because I'm building in the actuator for light, I use TTY as USB 0. So this one I know by myself, it's the USB. So with this, you can say apply. With that, in that case, you already set up the communication channel to the G code, and then you can say issue solution. Then it's gone. Now firmware is not detected, so basically we want to detect the firmware. Then we say okay. Then okay, this one it's also detected. Then there will be more informations. And here, actually, after it detects, it says okay, it has ABC, but there's no supporting for rotation ABC axis, but that's okay because we are using the 3D printer. It comes with the extruder axis E. We can use that. So this one, it's fine. We can dismiss that. And then after that, you can have the G code, the change flow control. Okay, so we usually follow the suggestion here. Then the milestone connect, I just say okay, now the milestone connect is good. So then we basically go to the basic. The connection is already done, and now we need to say access letter is missing, so this one we just use X, that's fine. And these are the Y and also the Z, that's good. And then C, here it's not sure, so we know it actually detects this E axis, and we know that it's extruder, and we also know that we connected the extruder into the into here, so into this nozzle head, so that's fine. we know it's it, so we can select accept. Now it's good. And then the pump. Pump is actually we actually used to make sure the nozzle head can attach the components. So what we can do here, because we are using the fan control here. So usually the fan control is come with the M106 command. So S256, that means turn on as a maximum, and then this one will work. And we also need to set the turn off, so it's 107, which is turning off. So with that, we are able to control the operator of the pump already, because 3D printer usually come with the control of a fan. So this is good as well. Now the next one is the vacuum. We don't have that, so we dismiss it. And then we have the camera light for the for button, and I think there's no, for the top and the bottom. So what we will build in is another operator, which is a script operator, so we can dismiss those two as well. So this is how it was. And then we can select the find issue solution. So this one again, it actually asks you to use the access C, and we know that it's an E, so we dismiss. And then now it's suggested some commands. We just do the setting here, connect, which is also good. We need to customize a little bit here. Global offset, that's also fine. We just select that and accept. Complete, okay. So with this, now you can see it's actually able to connect, but we still need to customize the home command. But so here, let's just do connect. So you will see it actually connect to the machine, and you can see it's homing pretty fast. And that is also not so good. If it's too fast, then when it moves to the depth stop, it will actually have a little bit of force of hitting the stop. Therefore, we need to customize the home command as well. There is another thing for the E-axis to move. This 3D printer comes with the protection that when temperature is low, it is not allowed the extruder to run, which makes sense for 3D printer. So now we need to also remove this limitation so that this axis can move. So if you see now, if I'm doing this one command, it doesn't work. Okay, so now to customize the home command, so what we can do is we go to here G code, and then we go to this one G code, and then we have the home command here. So as you can see, this is the go to home. Actually, the command go to home. So what we can do is M203. So this one actually sets the feed rate of the axis. So we say X 20, Y 20, and then we say Z is 10. So with this one, we also made a comment and say limit feed rate of. So this is basically to make sure that we are homing not too fast. And then after that, we need to set the extruder, the co-extruder. So basically we can, there is a command which is this one, M302, and you can see the flag, which is P0, so it's enable the co-extrusion checking, and then it actually specify the temperature as well. So what we can do is we can set to a lower temperature, which is lower than the room temperature, then it should work. So what we can do is actually M30. I just need to remember the format, M302, and then P0 as actually we can say 5. So that means above 5 degrees we allow the axis to move. So we say and then after that we also need to turn back the speed, the feed rate. So we can just set it to Y300, Z, usually Z30 will be good enough. So set the feed rate for movement. Okay, so with this one, we can do the homing again. So if you do this, you will see it's moving slowly. Okay, so previously without this command, we're not able to turn the axis, the extruder. So now if we do this, oh yeah, I think the setting is good. So what we need to do is I can do another homing. So so this is always been misleading. So here we got a camera top which is not really on the axis. So in this one you will see, so now if I do this, you can see the axis is actually moving. But right now the mapping is the rotation is not correct. So if you say 10, here it's actually not 10. So what we need to do is we need to calibrate this axis to make sure that it actually, when we set turn 10, it actually turns the 10 degree. Okay, so with this one, what we are going to do is actually we can create an axis. This is a reference map axis, this one, and then input axis we we say rotation and input is C. From my measurement, I actually know that 69 is actually corresponding to 360 degree in my case. So if I say here 10 degree, but I also need to change the head to use the correct axis. So I'm just say here, then you will see reference mapped axis here. So with this one, then if you say 10, it will then go 10 degree, and 100, it will just go 100. And then in order for you to know about how was the mapping for you, you can actually make a mark on top of this basically the nozzle head, and then make sure that it's on the location that you remember, and then you can actually go to console here. You can go to console here. You type G1M actually E. That's the axis 0. So you can say go to 0. Then you will see it's actually turned into 0 position. Then you make the mark, and then you say you do a try and error. So you say E69, and then you observe. So when the mark is coming back at the exact location, then you know it's 360 degree, and then that way you actually know what's the value for you for you the mapping value actually for your e-axis. So yeah, this is the thing that we need to know about. And here we say C mapped. So I just give a name that it's easier to actually remember. You see here C mapped. Okay, so this is the mapping, and now what we need to do is we need to see here the home command. It says okay, home command suggested, but here we already customized the home command, so we accept this one, then we just say dismiss, and then this milestone is good, so we say accept. So now it's for the dynamic safe for the nozzle. Actually, for me, I know that my Z I would usually I use 27, so that means when it's able to move over all the components and also leave some spaces. That's what I'm usually use. So I'm just set it to 27, and then I say accept the fixed safe Z. So then actually I have a fixed height. So this is good now. For you, if you want to use some other, you can use also dynamic. But I just use fixed safe Z for to be easier. Okay, so now we also need to set the lower soft limit, high soft limit, so that this tool is basically for that your machine is not over the limit of X. For me, I know this machine is from 0 to 222. So basically, I just go to machine setup. You can also move the axis, move the head to the axis, and then you say okay. Okay, maybe I can use here. I have x0, so which is accepting, and the y for the high limit. I know it's 220 for me, so I just come here, and I say 220 and apply. And then here, if I do this, you'll see x is gone. Set the safe z of n. Okay, so this is okay, for reference nozzle n. So we already at the 27, so we can accept, which is good. And then we have the y. It's also the same story. So y we have 0. So this is the lower side. Okay. And this one, for this one, we go to y, and I know for my y it's also 220, which is good, and I'm just enable it. And then the y should go, and the same story for z. So low soft limit, and for z is also here. Z, it's also 0, and then soft limit high, I just put in 100. I don't want it to go really high because I mean for this printer it can go like more than 200, so I don't want it to go that high. So I'm just apply here, then it's also good. And then we have manual nozzle tip change location. So this is basically the location that we want to change manually and to make it easier to remove, plug down, and put in a new nozzle. So here, I think this location is already pretty good. So I just do the accept. And now the feed rate and the other setting jerk, and we can actually try that. So in here we can actually give a feeding. So here right now this is very slow, right, as you can see. So what I'm gonna do is, oh yeah, so there is one more thing. I think this slow is let me see, 2 path bit rate. Okay, so if I go to here, this is because the feed rate is already in the different way of the driver is in different way of moving, therefore it will be slow. So if I say the other one, so Okay, it's still slow. Okay, and rotation. Okay, so I just continue with the other one. Wrapping around, that's good. Choose advanced motion control, okay. This one, and okay, so this one actually, the one I was looking at, so it's actually limiting the feed rate. I just accept it, and then I was, now you can see it's really moving fast. But then I don't want it to be that fast, so let me see. Or I want actually to want it to be fast, but I don't want the acceleration to be too high, because that will then cause the component to be jump off or shift the location. So I just set this one to 600 for example, and then I can just check. So you can see it has a nice start and stop acceleration because of the jerk, so which is good. And the same thing I want to do also for the y-axis, so you can see. Okay, so it's on the, under the limit, so it doesn't allow you. Now it's good. So we have here also the Z. So what happened to so you can see. So if the up down movement is also like without the good acceleration deceleration, then it will also hit the feeder tape, which is also not good. So I just set it to just so you can see now it's much smooth at the end. So you make sure that the nozzle tip doesn't bump into the feeder tape, then causing the component to be bounced off. So these are also the thing we need to notice. Okay, so now it's only those four, and we have already set it. The other thing is then for the rotation. What you just see is because we limit the range, then it will at some point turn back. So you will see this long turn even with even if we only turn 10 degree, then it will need to go back. So that's why. Okay, so now I will try to show you again. So in here 100 degree, so you see the turning second time, third time, and then if we push more, it actually above 360, then it goes back. So to do this one, one of the reason is that there might be some, for example, how do you say it's not 100% accurate. So when you're always turning one direction, there will be accumulating of the error. So when I limit the range, so sometimes it actually turns always back and forth, then the error will be cancel out. So that's why I doing this limit range. Okay, so this part is also done. I just dismiss this one, dismiss this. Okay, so now actually I can go to the next one. So the calibration one is actually taking quite some time. Till this moment we have finished the basic setup of the system. So the next one is the vision, which I will cover in the next video. So if you like my video, please like and subscribe, and see you in the next video. Cheers.